Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to take our histogram and we're going to put the information into a table, into a tabular form. And this has a funny name of being called the frequency distribution, which I say is funny because we've also used frequency distribution to describe a graph. But this tabular presentation called the frequency distribution, table, data, let's call this table, data, or frequency distribution. Okay, that's our title for today. Is we're going to make a frequency distribution, or table of the data, from this. This is our first 20, our data set, which is the first 20 digits of pi. And then we made, if you go over to the far right, we made a dot plot. Here's the dot plot of it. And then, after that, we constructed a histogram. And I have this pretty histogram that we made in our last video included here as well. So here's what the frequency distribution is. It is the table form, the table format of a histogram. That's all it is. I know you wanted it to be harder, but it's not. So here's what we do. We're going to make a few little changes to it as we go, but here's the basic one. The basic one is we have our class boundaries. And I'm just going to put, we'll put class, because you're going to see it can be used a little loosely, but it will be specific for now. Class boundaries. Now let's just put class. We'll do class. And then I'm going to put in parentheses boundaries. You'll see why. Boundaries. So the class boundaries. I'm going to leave then we'll have our frequency. All right, so our first class, we just look at our histogram, goes from 0.5 to 2.5. And it has a frequency of, the width of the class is 2, the height is 2, so it has a frequency of 4. So remember, it's the width times the height. And the next class is 2.5 to 4.5. And it has a frequency of, it looks like it still has a width of 2. It has a height of 3, so it has a frequency of 6. Our next one is 4.5 to 6.5. And it has a width of 2. It has a height of 2, so it has a frequency of 4. The next one is 6.5 to 8.5. Has a width of 2, has a height of 1.5. 2 times 1.5, that's a frequency of 3. Our next class goes from 8.5 to 10.5. It has a width of 2, also has a height of 1.5. We've done that. We know that's 3. Put a line under it, and there we go. That right there is the most basic table that we can create. One thing you always want to do, or I would encourage you to do, is to add up those frequencies and make sure they total to 20. So if I go 4 plus 6, that's 10. 10 plus 4 is 14. 14 plus 3 is 17, plus 3 more. That's 20. So my total frequency is 20. There's 20 data values. We can see that in our data set. So that worked out just fine. And that's the most simple form. Now, I said earlier that class can be used a little loosely. So let's put class over here again. But this time, we're going to call these the class limits. So let me show you. The class boundaries create a continuous graph so that, in other words, one bar of the histogram is adjacent to another bar. But notice that none of the data values are on the class boundaries. There's no data value of 2.5. All of our data values are whole numbers. So if you go just inside of the boundaries to the data values, for example, the first class has data values from 1 to 2. So in other words, if you describe a class by its lower data value and its upper data value within the boundaries, those are called the class limits. So the first class, if we look up, let's do it this way. Our first class has boundaries right here of 0.5 to 2.5. These are the boundaries. I'll abbreviate boundaries. And then these, the actual data, that's the lower, which is the 1, the upper, the 2, these are the limits of the data. So for example, if I had a class of 3, for example, maybe I had, this is just an example, maybe I had my class boundaries were in 3 units, so they went from 4.5 all the way up to 7.5. If those are my boundaries, then my limits would be 5 and 7. These would be my limits. Okay? So the limits are the lowest data value and the highest data value within the class boundaries. So if we look at our first one, our first class, this is why we just say it generally, and then the reader just needs to look at context to decide whether they're boundaries or limits. Our first class then is 1 to 2. Our second class is 3 to 4. Our next class is from 5 to 6. Our next set of class limits are 7 to 8. And our final ones are 9 to 10. So I wrote 9 to 10, 7 to 8, things like that. I'm going to erase those for a moment. So it's not uncommon, it's actually quite common, to see instead of the word 2, I just think it's more clear. But sometimes you can just do like a long dash, 7 to 8, 9 to 10. You can do that as well over here on the boundaries if you prefer that format, 6.5 to 8.5, 8.5 to 10.5. And that works just as well. So that's the difference between class boundaries, class limits. So I want to just give you an example. Say, what if I gave you class limits? No, let's do that. Yeah, we'll do boundaries. Let's do class boundaries. Of 1.05 to 1.35. What are the limits? What are the class limits? Question mark. Okay. Well, think of it this way. Remember, the boundaries always split the units. So in the easy example of digits of pi, we said that if our data was in whole numbers, our boundaries would be the next half unit below that. So in this case, think of if we had a number line here. If our boundaries are in hundreds, then that means, so look, boundaries, these are in hundreds. I'll do hundreds like this. So limits or the data limits or data must be in tenths. So in other words, 1.05, just above that would be 1.1. So here's 1.1. And the next data value would be 1.2. And the next data value would be 1.3. And the next one would be 1.4. And maybe I could go below it. Who knows? This may not be the lowest one. So below 1.1 would be 1.0. And I could go even below that. I could go to 0.9. And so look at this. Then my limits are 1.05. That's right here. I'll go this way since I'm running out of room. Up to 1.35. So there you go. Your limits then are the lowest data values possible within that boundary. So our limits in this case are going to be right here. From 1.1 to 1.3. So who knows if there could be dots, in a whole bunch of dots over 1.1, some dots over 1.2, some dots over 1.3. But if 1.05, 1.35 are boundaries, there's no dots. The next dots would occur maybe over 1.4. Something like this. Okay, so the limits. See, notice I just said limits. You could also say class limits. Limits are 1.1 to 1.3. So the point, a histogram is a graphical form of the tabular frequency distribution, or you could say that the picture of the tabular frequency distribution is a histogram. I hope that helps, and thanks for watching.